Hey everyone, welcome back to my channel. In today's video, we are diving into another important solid principle, the interface segregation principle. What happens when one interface tries to do everything? You end up implementing methods you don't even need, and your class becomes a dumping ground filled with not implemented exceptions. Maybe it works, maybe it breaks at runtime, but one thing's for sure, your design becomes messy, confusing, and error prone. Let's not go there. Let's talk about how the interface segregation principle helps us design clean, focused, and trustworthy interfaces. The kind that do exactly what they promise and nothing more. I will walk you through a quick example, show you what not to do, and then fix it the right way, step by step. Ready? Let's get into it. So, before moving further, let's understand the purpose of interface. That's very important, right? An interface is like a contract. It tells the user, here are the operations I support. You can depend on me to do these things. When another developer, maybe from another team, looks at your interface, they don't know your implementation. They trust the interface. So, if your interface has three methods and the developer calls one of them, they expect it to do what it says, not throw an exception, not be irrelevant. But when you design an interface with too many methods, not all of which make sense to all implementers, now you are violating the trust. You force your consumer to depend on and understand things that they don't even need. And that brings us to the interface segregation principle, a principle that simply says no client should be forced to depend on methods it does not use. Keep your interfaces clean, focused, and minimal. Only include what's absolutely relevant to that behavior. Honestly, the interface segregation principle is one of the simplest to understand among solid principles, and applying it correctly can significantly improve code maintainability and clarity. Let's take an example and understand. Let's say you are building a system where we have different types of workers. So we start with an interface, iWorker, which defines what a worker should be able to do. This interface says every worker should be able to work and also eat. Seems reasonable, right? At least for humans. So let's implement human worker. So we implemented human worker and this works fine. Human work and eat. No issues here. Let's implement another worker, the robot worker. Now we implemented the robot worker as well. It can work, but it can't eat, right? But we are forced to implement eat anyway. So what do we do here? We throw a not implemented exception. That's the violation of interface segregation principle. Let's discuss the issue with this design. Robot is forced to implement a method it doesn't need. Second one, client might accidentally call eat and get a runtime error, not implemented, right? It is of course misleading API, right? It suggests all workers must eat, which is not true for workers like robot. It also breaks what we discussed earlier, the trust in the interface contract. It is of course not flexible for future changes as you might end up having not implemented exceptions in all its extensions. Now, all this tells that this is a clear violation of interface segregation principle. Let's try and refactor this code following this principle. So what can we do? We can break the interface into two, one for working and one for eating. Let's do that. Now all those who eat implements ifeedable. Let's refactor the human worker class. Human worker still does both, work and eat. And no change. Only change is for human worker we have implemented both the interface. Let's implement robot worker. Now see, robot worker only implements what it needs. That's iWorkable. No more fake eat methods with not implemented exception. That's a cleaner, safer, and more expressive interface. So what did we fix by following ISP? Now, no unnecessary methods for robot worker, right? Safer and clearer interface contracts, easier for developers to use without confusion. Now it supports future expansion. Like maybe later on you would like to implement interfaces like iSleepable, iDanceable, etc. And of course, now it aligns with interface segregation principle. So to wrap it up, the interface segregation principle is all about respecting the contract. Give your consumer only what they need, no more, no less. Avoid forcing them to implement or depend on irrelevant methods, and your design will be cleaner, safer, and more flexible for change. That's all for this video. If this helped you understand ISP better, give the video a like and drop a comment. Thanks for watching and keep your interface clean.